Now let's just see the next question. Question number 2 says that if two circles intersect at the 2 points, prove that their centers lie on the perpendicular bisector of the common chord. They are lying, their centers are lying on the perpendicular bisector. So let us suppose if I'm just drawing up the two circles over here. So let us this is the first circle that I'm taking, and it's a circle. Its center is nothing but O, let F, and let us suppose again if I'm taking another circle over here in such a way that they are intersecting at the two common points, as you can see. And let us suppose if I'm just taking its center as nothing but O dash, and as you can see over here, it is actually intersecting, they are intersecting each other at the 2 points. Let us suppose if I'm calling it as P, let us suppose if I'm calling it as Q, I'm joining this O dash together, I'm joining this OP together, this O dash P together, this OQ together, and I'm forming up this. Again, let us suppose if I'm joining the PQ again, if I'm joining this PQ, if I'm joining this PQ, so what we have to prove actually, we have to prove that their centers are actually lying on the perpendicular bisector. So it means that PQ is nothing but a perpendicular bisector. That exactly what we wanted to prove over here. Furthermore, if this angle would be 90 degree, then it is quite enough for us to prove that their centers are actually lying on the perpendicular bisector. They are lying on the perpendicular bisector of the common chord, means they are lying on the perpendicular bisector of the common chord. So let's just move on further and to prove that they are lying on the perpendicular bisector. So let us suppose if we are just starting with the two triangles. As you can see over here, we have the two triangles that are formed. This is nothing but the very first triangle, which is O dash, and the other triangle is QOO dash. So let us suppose if I'm just taking the two triangles in triangle POO dash and triangle QOO dash. First of all, we can see that OP is nothing but is equal to OQ. This side is equal to this side. Why so? Being the radii of the circle. Furthermore, we can say that this O dash P is equal to O dash Q. So further we can say O dash P is equal to O dash Q. Again, why so? Because it is nothing but the radii of the circle. It is nothing but the radii of the circle. Furthermore, we can say that O dash is equal to O dash. This is nothing but a common side. Now, what can we say about the two triangles? It implies that since these three sides are actually is equal to each other, it implies the triangle POO dash is congruent to the triangle QOO dash by SSS congruence criteria, and hence if they are congruent to each other, it implies that the angle POO dash is equal to the angle QOO dash by CPCT. We can say this fact that this angle is actually is equal to this angle. Now let us suppose if I'm just talking about the two small triangles over here, that in triangle PO, let us suppose if I'm calling this particular point as nothing but N, PON, and triangle QON. First of all, as we can see over here, OP is nothing but is equal to OQ, being the radii of the circle, implies furthermore we can say that we have the other thing as ON is equal to ON, which is nothing but a common side. Moreover, we can say that the angle PON is equal to the angle QON, which we have already proven case. So what can we say about the two triangles? It implies that using these three conditions, we can say that the triangle PON is actually congruent to the triangle QON, and if it is congruent, it implies that PN should be is equal to QN by CPCT. Why they are congruent to each other? Because of the side angle side. By SAS congruence, we can say that they are congruent to each other, and hence by CPCT we can say that this this side is actually is equal to this side, and if this side is equal to this side, moreover we can say that the angle PNO is equal to the angle QNO by CPCT. We can again say this fact that this side is this angle is also is equal to this angle, and furthermore we can say that the angle PNO plus the angle QNO is nothing but forming up an angle of 180 degree by the linear pair condition, by the linear pair axiom, which implies that since we know about this particular fact, so it implies that both of these angles are equal to each other, which says the angle PNO twice of is equal to 180 degree, which implies the angle PNO is nothing but is equal to 90 degree, which is same as that of the angle of QNO. Now you can see this fact that this angle over here is nothing but 90 degree, and this angle over here is nothing but 90 degree. Moreover, this side and this side, they are actually is equal to each other. So what can we say? That the two circles intersect at the 2 points. We have their centers lying on the perpendicular bisector. So we can say from this particular fact that the centers O and O dash of the circle lie on the perpendicular bisector, because you can see all by yourself that this angle over here is nothing but 90 degree, this angle over here is nothing but 90 degree, this side is actually is equal to this side. So this is definitely but nothing but a perpendicular bisector to PQ. This is nothing but a perpendicular bisector to PQ. So they are lying on the perpendicular bisector of the common chord. So as you can see, this is nothing but the common chord over here. PQ was actually the common chord over here, and OO dash actually existing as nothing but a perpendicular bisector. Not PQ is the perpendicular bisector, OO dash is actually existing as a perpendicular bisector of this particular intersection of two circles. So this is nothing but all about the question number 2.